Okay, I'm in a place called Hernando Beach, or Pine Island. It's north of Hernando, or Bayport, and Hernando Beach. This is just give you a quick look around here, this beach. And what I wanted to do was show you my tripod and where it's sitting at here. And the depth of the water is actually just a couple of feet down, maybe arm's length from this little seawall. Oh shit, getting splashed. And I got a good view of the north too, so maybe I'll set up over here and shoot northward too. But I got boats way out here. What I want to do is shoot towards Hernando Beach. I'm going to scour this edge right here all the way across, all the way out to this point, and then I'll go on the other side and see what I can do on that side. As long as I don't get rained out, because there is rain in the forecast, but it looks like it's all inland. Oh, there's the sun. And there's our horizon. Okay, the observation deck that you seen a little bit earlier was off limits. They had it fenced off to where you weren't allowed to go on it. But I'm about 2 miles away from Bayport at Pine Island here, and you can see where Bayport is. Got some little pins showing you where that's at. And then we'll go on with some my first observation video from this. Okay, I found a new place to dwell. I'm at a place called Pine Island, which is north of Bayport. Alright, I wanted to bring up angular resolution limitations to not only our eyes, but also even with zoom cameras, there's a limitation. And then you have some other effects that actually obscure your view. One of them is basically the miraging or the mirroring that occurs, and what you will see in a very slow, skinny area is a mirror that will actually just mirror the sky, and within that mirror it does block out things farther in the distance. Going out and doing observations after observations, one would recognize this and realize that this is occurring. It's almost hiding in its own reflection. And you can find that out and by just doing some observations of mirages on the road. You can find that things get blocked out that are farther in the distance, or that is actually down in this mirage. It literally creates a ramping effect. And this day, this is July 21st, and this was my first video at Pine Island that I did. And you can see these boats up on the edges there. I'm pretty sure that those were boats just back there. But there's very little land or rock area sticking up out here. And on a real low tide, you'd get some rocks maybe sticking up. But because the tide is higher, you're not going to get any. Now, you see this boat and you see its wake. Now, this is approximately 5.5 miles away. And my tripod is approximately 6 feet off the water. I'm using a manual tripod. It doesn't stick up as high. I don't have my remote on it. So I'm a lot lower with that tripod, and it's actually a shorter tripod. But one of the good things is that you can see where I was standing at. I'm not very high off the water, people. So I should not be able to see the wake of this boat. The earth curvature should be cutting it off. The other thing is if I'm standing on the top of the ball or on top of the globe, anywhere that I stand, I should be always looking down. So if I was always looking down, everything should dip away from me, not come up to eye level, as we see. And this eye level thing, this is actually below eye level because the horizon does go further out, but very slightly further out. And that's where this mirroring takes place. But just look at this boat. I mean, it's crazy that, I'm able to see this, but, your angular resolution limit will only go so far. And then the only thing that you'll pick up past this limit is anything that sticks up higher. And anything that sticks up higher will appear to be cut off. But, this video show that there's there's something missing here. And what's missing is the curvature. Because you'll see boats and objects farther past this boat here, which again, this boat is in the Hernando Beach Channel. There's the channel markers right there. And then there's closer channel markers up closer to me. And those are the Bayport channel markers. And, when you look at the distance between those channel markers, look at this boat. It's past the other boat. It's well beyond it. When you're looking at these channel markers and then you see the other channel marker that's closer to me, the Bayport ones, there's 3.5 miles between the two. All right, let's just say 3 miles. So you got 3 miles in this skinny little strip that's out there. And I'll be able to show you this on another video that I took this day. I was out there for a couple hours filming and observing. And look at this boat too, going in between those channel markers. And all these channel markers are approximately the same height. They're not exactly, but they're approximately all the same height. And there's one of the channel markers, that's Bayport. So you see what I'm talking about is this, there's 3.5 miles between that and the edge of that water. So the angular resolution, once you get it cut so much, it gets so sharp, you can't resolve it. And then you got this little boat that's cruising along here, and you can obviously see its wake. It's pushing out. Well, you don't see the wake that it's pushing out on the other side of the boat. Why? Because the wake that's closer to me is actually blocking out the other wake. And you can see as this boat passes by other objects that wake will cut out some of the other object, or the lower portion of some of the other objects or other boats. And that's why I say I've got so much footage from this day, because I was like, wow, I'm getting footage here that I should not see. And that's why, all these people that come over from the Globe people, here's Bill Watsrack, all these people that come from the Globe, they're always saying, it's pulling things up from behind the curve. Yes, light can bend, but I don't believe that these objects are going to bend up above and be placed perfectly in line with our eyesight. That's asking a little bit too much. Just like their magical theory of gravity, it explains everything. It's their God, God of the ball, ball, whatever you want to call it, the globe. But I see things a whole lot different today than what I did 3-4 years ago. And like I said, originally I went out to debunk flat Earth. Even though I was kind of going along with it, I said, I don't know. There were certain things I seen that I said, I'm going to debunk this. And when I actually got out there to debunk it, I was like, wow, there's no debunking, because you have to do some research first, because there were things that I saw that really made me question some things like the mirroring, the miraging, everything. And then you have your perspective of how high you are off the water. So of course, with my pipes, I was able to show that your height, even on a flat surface, will make something rise and fall. And that's just due to perspective of where you're located as far as your height goes. It doesn't just work on a globe. Now, here comes a part here where I slow it down 50%. I didn't put in a transition. But look at this boat that's farther out there. I mean, look at the size of that boat. I mean, come on, and look at the waves, how those waves or the wake blocks you out from seeing it. You know, this tells you something right here, or it should. I mean, you can't even really make out the person on the boat, but you can make out that this whole boat is above the water. And of course, that boat's rocking out there. It's in the waves, it's in the wake, so it's rocking back and forth. So you might get the front go down, the back go down. So it's out there teeter-tottering on the water. But, here's the angular resolution at play here, where you're only going to be able to see what's above that visible water line. And this is what a lot of globe people miss. They don't look at this as actual proof. They'll tell you, they'll bring up the bull crap that refraction is pulling it up from behind the curve. Well, have they ever thought that refraction can actually pull things down, like we've showed many times before? Not just me, but other channels have shown that refraction can literally pull things down, not up. So what happens is once you get past this visual water line, okay, the visible water, there's more water back there, but we're at such a sharp angle, you cannot see past it. And within that area above this visible water is actually what's going to cause your objects to be drawn down into the mirage or the mirroring. And even here, look at this boat. You can obviously see this whole boat is above the water. And you'll see it kind of rocking and the waves lapping over it. But again, you're looking at small waves because they're so far out that you can hardly see them. Look at the white caps too. And I know that this footage is very shaky and it's hard to see with it shaking so much. But again, this was a very windy day. And I think that wind also had something to do with blowing the humidity away and allowing me good visibility this day. The other thing is it's a high tide and the wind is blowing inland, so it's literally blowing the water up into these bays. Now, can that affect the water farther away? Why, of course it can. It's you can get a blower and put it on a little kiddie pool and keep it at a certain speed, say, you got 20 miles an hour on it. You can push that water off to one side and keep it up up onto one side of the pool. Very simple test to do, and it's pretty logical that this can happen here out in bigger bodies of water. I'm an avid fisherman, so I've been out during times where the wind was coming out of the east and the tide was going out, and it was supposed to be a low tide, yes, but oh my goodness, woke up one morning, we were in a fishing tournament. It was an all-night fishing tournament, and woke up and there was no water to be seen. All the water got pushed out by the high winds, and I mean, you could see rocks and land as far as your eye could see. And that's when I wish I would have had a good zoom camera so you could zoom out and actually see all these islands. Now, it took forever for that water to get back in because the wind continued to blow out of the east.
So we sat in the mud for hours waiting for that tide to finally force itself back in. And that's how hurricanes work too. You know, you get the storm surge. It's that big wall of water being pushed up in front of it. Now, you can't tell me that these big walls of water can't affect your view. It's like going to Hawaii and standing on the shore watching surfers. You know, you got the water that's right up on the shoreline, and then you watch these surfers get up on one of these big 30-foot waves. That 30-foot wave is totally blocking your horizon line out. It's totally blocking your line of sight. So, yes, you know, waves, swells, all of that can affect how a boat appears and looks the farther it gets away from you. So people want to say that, you know, hey, you know, follow a big ship wide awake and you'll see how it gets cut off. Yeah, but they also don't realize that these big ships are in some rough waves, especially on the east coast of Florida, that there's waves and swells out there that, you know, these boats are down in. Number one, they sit down in a wake because they produce a wake. So, you know, when they're moving, they're pushing water away from them. So they're actually down in a swell that they produce themselves. So this is where you get this cut off appearance where things seem to get cut off, but it's not getting cut off due to the curvature of Earth. It's getting cut off due to your perspective of how high you are on the land, you know, or how high you are off the water, and how far back away from the water you are on the land. I mean, you could be, you know, 3 miles in, up higher, looking way out over the top of land, seeing water, and yeah, you're gonna still have the same issue. You're not gonna be high enough to see anything. It's like taking a board or a piece of paper and laying it, holding it up flat, straight up and down in front of you, and then lay it down flat, and then try to look at it on an angle. There's going to be a point where, you know, it's just this little sliver of a piece of paper. Matter of fact, it's, you know, if you get down low enough, actually at true eye level, it's just going to be a little sliver, a little slit. Okay, so again, our eyes can deceive us, but our mind can deceive us more with what we put in there as far as what we were taught to believe. And this is where I'm drawing my line and going back and questioning my beliefs that I was taught as a young man. You know, that we're on this spinning ball of water, spinning in space, moving at 60-something thousand miles an hour around the sun, spinning at 1,040 miles an hour at the equator. It just does not make sense. Until, you know, they throw in that theory of gravity. But here's I changed video. That was the end of one video. But what I wanted to do on this one is just show you the area that I'm viewing, and I'll let this audio kick in by itself and let you see where I'm filming from and the area that I'm filming.
I'm going to give you this shot right here. And look here, ain't